Okay, the second show you know in section 2.4 in rational numbers is each of the following numbers a perfect square? Explain. So a perfect square by definition, has an identical pair of factors. So if we think about what perfect squares could be, so we know 25 is a perfect square because you can create 25 by multiplying 5 by 5. So 25 therefore is called a perfect square. We know 100 is a perfect square because it can be created by multiplying 10 by 10. Okay, so 100 is a perfect square. But whole numbers are not the only ones that can be perfect squares. You can also have any rational number be a perfect square if what all rational numbers can be, not always will be, perfect squares. So when we deal with fractions, which of course are rational numbers in fraction form, if we look at the first one, 121 over is, oh, let's go back to this one. So in order to determine if it's a perfect square, I have to be able to square root 25, and in a calculator it would tell me that if I put the square root of 25 in a calculator, square root of 25, it says 5. So it tells me what number you multiply by itself. Same thing with 100, the square root of 100. If I put that in a calculator, it'll tell me 10, so therefore 10 by 10. But when I ask the question, is the square root of 121 over 64 a perfect square? Is it a perfect square? I have to know what number multiplied by itself will give me 121 over 64. Or the exact same question would be, that would be 1 and 57 over 64. These two questions are the exact same thing, right? The square root of 121 64ths is a improper fraction. The square root of that exact same number as a mixed fraction would be 1 and 57 64ths, I think. So therefore, because we have rational numbers in fraction form, the same thing that held true over here, what number multiplied by itself gave me this number, holds true for the same thing in fraction. The only difference is what fraction multiplied by itself gives me 121 over 64. Now, if the rational number is a perfect square, then both the numerator and the denominator will be perfect squares, okay? So 121 is a perfect square because we know that 11 times 11 is 121. So 11 times 11 means the numerator is a perfect square, and 8 times 8 is a perfect square. So therefore, what number multiplied by itself gives you 121 64ths? It's 11 eighths over 11 eighths. So therefore, 121 over 64 is a perfect square. Now back to what I said before, that the same question, 1 and 57 64ths, is the same question as what is the square root of 121 64ths. If you are given a mixed fraction, you cannot determine what the square root of a mixed fraction is. You must first convert it to an improper fraction, and then that's the same question. So because I had to do it, if this was the question that I gave you, you would first have to convert it to this, then ask yourself what fraction multiplied by itself, and then you would know that yes, 121 64ths is a perfect square. For the second question, B, is 1.2 a perfect square? 1.2 a perfect square. That means that there would be a number multiplied by a number that when you do that, you get 1.2, okay? So is the square root of 1.2 going to be a perfect square? Now, when you are given decimal numbers, the strategy is if you are going to do it without a calculator, what you want to do is you want to first convert that rational number in decimal form to its equivalent value in fraction form. So 1 and 2 tenths, if I read that as being 1 and 2 tenths, then that helps me write it as a fraction 1 and 2 tenths, right? 1 and 2 tenths. So really what I'm asking myself is this, because these are both the same thing, is this going to give me a number, or is it going to be impossible to do that? So because this is a mixed fraction, remember what I said in the last example, you want to convert this to a improper fraction. So 10 times 1 is 10 plus 2 is 12. So this is the same question here. And the question now is the square root of 12 tenths going to give me an answer? Is it going to be possible? Is 12 tenths a perfect square? The answer is no, it's not. And why? Because there is no fraction that when multiplied together gives you either 12 or 10, right? So therefore, 12 tenths is not a perfect square. Okay, now if I want to confirm what I just said, if I take a calculator and says what is the square root of 1.2, it will give me an irrational answer. So remember we said before when we defined rational numbers, they are numbers that are either repeating decimals or terminating decimals. Numbers like pi, or in this case the square root of 1.2, if this calculator had the ability to go on forever, you would never have a repeating pattern in that decimal. Okay? It would be a non-repeating, non-terminating decimal. So therefore, the square root of 1.2 does not yield a terminating decimal or a repeating decimal. So for question C, you have again a decimal, a rational number expressed in decimal form. So is the square root of this number going to give me a terminating decimal? So again, I'm going to look at it as being 9/100ths, okay? And then ask myself, what fraction multiplied by itself is 900? Is it possible? And since both the numerator and denominator are perfect squares, we're going to have 3 as our numerator, we're going to have 10 as our denominator. So therefore, expressing that as a rational form, I know the square root of 9/100ths is 3/10, and in decimal form, 0.3. So 0.3 multiplied by 0.3 will give us 0.09. Now, just as an extension, if I gave you this on a test, which usually I do, we're going to call this C1. If I said, is 0.9 a perfect square? Is 0.9 a perfect square? Here's where people use that same idea of the last question. They say, well, 9 is a perfect square, so probably 0.9 is going to be perfect. But if I look at it in fraction form, that's 9/10ths, and there is no fraction. There is a numerator, but 10 is not a perfect square, so therefore 9/10ths is not. And if I confirm what I just talked about with a calculator, the square root of 9, sorry, clear. The square root of 9/100ths is a terminating decimal, 0.9, but the square root of 9/10ths is an irrational number, right? That will not repeat ever. So it's 0.9 is not a perfect square, but 0.09 is.